Okay, so imagine for a second that you could build machines smaller than a single blood cell, or create materials that are 10 times stronger than steel. What about curing diseases at a molecular level? Now, this isn't science fiction anymore. This is the real world of nanotechnology, and it's already here. As a research engineer, I want to give you a look into this incredible field and how it's about to change, well, pretty much everything. So let's start with a bit of a puzzle. What could a high-performance tennis racket possibly have in common with a revolutionary cancer treatment? I know, it sounds kind of impossible, right? But the answer lies in a world so small it almost defies imagination, a world being built right now with nanotechnology. All right, so here's how we're going to break this all down. First, we'll try to get our heads around the absolutely mind-boggling scale of the nano world. Then, we'll get into how we're actually learning to build things at the atomic level. After that, we'll look at some amazing applications in medicine and materials science. And finally, we're going to have to tackle some of the big ethical questions this powerful new tech brings up. To really get what nanotechnology is all about, we have to totally recalibrate our sense of scale. I mean, we're not just talking about tiny things. We're talking about the fundamental building blocks of our world, the atoms and molecules themselves. So a nanometer is 1/1000th of a meter. That number is so small it's hard to picture. So try this. If a single marble were 1 nanometer, then 1 meter would be the size of the entire planet Earth. Yeah, a single human hair, that's about 80,000 nanometers wide. And see, down at this tiny scale, materials start to behave in really weird and wonderful ways. We're not just shrinking stuff down, we're actually tapping into brand new properties to create materials with abilities we've never seen before. So how in the world do we actually build things at this incredibly small scale? Well, we have two main approaches, and they're almost like philosophical opposites. Think of it as the difference between a sculptor who carves away material to create something and a bricklayer who builds something new from the ground up. So, on one side, you have the top-down approach. That's where we start with a big chunk of material and we etch or carve away at it to make the shape we want. This is the classic method we've been using for decades to make all the computer chips that power our lives. But on the other hand, you have the bottom-up approach, which is way more futuristic. With this, we're literally trying to assemble new structures atom by atom, kind of like how nature does it. And this right here is a perfect example of that top-down approach in action. For decades, we've gotten really, really good at using this method to cram more and more transistors onto silicon chips. That is exactly why the computer in your pocket is millions of times more powerful than the ones that sent us to the moon. But now, let's look at the bottom-up approach, because this is where things get really exciting. Instead of carving, we're building. It's like we're trying to copy nature's playbook. You know, nature assembles these incredibly complex structures, like DNA, from the bottom up, one little molecule at a time. This, right here, is the future of manufacturing. And it's this ability to build like nature that is driving an absolute revolution in medicine. I mean, we are on the edge of a brand new era of healthcare, all thanks to nanotechnology. You know, the ultimate promise of nanomedicine is precision. Think about it. Traditional medicine often works by flooding your whole body with a powerful drug just to hit one small target. It's kind of like using a sledgehammer for surgery. With nanotechnology, we can design therapies that go exactly where they're needed and only where they're needed. We can finally operate on the same tiny scale as the diseases we're trying to fight. We're developing a whole new generation of medical tools that can interact with our bodies at the molecular level. We can use these tiny nanocapsules to deliver drugs directly to cancer cells, leaving all the healthy cells alone. We can use nanocrystals to literally light up tumors for surgeons, making them way easier to remove. And we're creating these tiny labs on a chip that can diagnose diseases in minutes from just a single drop of blood. It's incredible. I know, this looks like something straight out of a sci-fi movie, but this is the future we're actively building towards. Imagine tiny little robots patrolling our bloodstream, seeking out and destroying cancer cells or viruses before they can ever do any harm. This is the amazing potential of nanomedicine. But the impact of nanotech doesn't stop with medicine. It's also being engineered into the world all around us, making the things we use every single day lighter, stronger, and way more efficient. And that brings us right back to our opening puzzle. The link between that tennis racket and a cancer treatment is this remarkable material called carbon nanotubes. These tiny tubes are insanely strong, like 10 times stronger than steel. So when you add them to a tennis racket, you get a much lighter, more powerful frame. And in the future, we'll use those exact same nanotubes to build those tiny medical robots. It's the same amazing material, just applied in two totally different ways.
Nanotechnology is also completely transforming how we generate and use energy. We're creating solar cells that are so thin and flexible you can literally print them onto almost any surface. Just imagine a future where our clothes, our windows, even our roads could generate electricity. This is the kind of clean, abundant energy that nanotechnology could unlock for us.
But with this incredible power to re-engineer our world, that also comes with some heavy responsibilities. As we get more and more control over matter at the atomic level, we have to start asking ourselves some pretty tough questions about the kind of future we really want to create. So we have to move forward with both excitement and caution. It's so important to celebrate the incredible potential of nanotechnology, but at the same time, we have to be really clear-eyed and realistic about the potential risks. And there are some really serious challenges we have to address. For one, we don't yet know the long-term effects of these new nanomaterials on our bodies or on the environment. We have to be so careful not to repeat the mistakes of the past, like we did with asbestos. And what about privacy? When sensors become so small that they're basically invisible, how do we protect ourselves from constant surveillance? These are really difficult questions, and we need to find the answers. The good news is that scientists, ethicists, and policymakers are already thinking hard about these issues. They're working to create guidelines for responsible development of nanotechnology, and they're calling for a global conversation about the kind of nano future we want to build together. And that's exactly what we need. So we're left with this really profound question. For the first time in all of human history, we have the power to actually program matter itself. We can literally write the code for the world of tomorrow, one atom at a time. The question is, what kind of world will we choose to create? The answer to that is going to shape the entire future of our species.